Okay. Mm. Okay. So in this video, uh, I'm with another interesting problem. This time I'm with a problem which is related to the extra algorithms. Uh, if this problem is not a direct application of the extra, but there is slight modification. Although this is not the tougher, this is not the problem that can be solved using direct the extra algorithm. So if we will read the statement of this problem, then this will get this everything. Like you will in case of the extra, this will have to find the maximum type things, maximum kind of things. But in this case, we have to deal with maximum. Sorry. In the extra, you have to find the minimum kind of things. But in this case, we have to deal with maximum kind of things. Okay, so uh, like first of all, I would like to explain you what is problem. Okay, so this problem has become interesting uh, because first of all, it is not the direct application of any algorithm. Secondly, it is not that tough to solve it if you are having the good grasp of this diagram, how it works behind the scene. Okay, so let me discuss what the problem is asking. Okay, so let me discuss the statement of problem. Basically, you are given the undirected graph, and you have to calculate the the maximum probability of reaching from the source node to destination node. Okay, so you are given with those source node and destination node, and you have to calculate the maximum probability to reach from source to destination node. Basically, the probability is given for each and every nodes, and you have to calculate for that. Like suppose you are given with these nodes. Okay, so hmm, these are four nodes, and this is your source node, and this is your destination node. So suppose it is this is P1, this is P2, and this is P3. Okay, and this is P4. So in order to reach, so how many paths are possible? In order to reach from source to destination, then you will say there are two paths to reach from source to destination. First one is this, and second one is this. Okay, and of then what we have to do, we have to calculate the maximum probability of the paths. Like if P1 is the probability of this path, and P2 is the probability of this path, P3 is the probability of this path, and P4 is the probability of this path. Okay, so in order to reach from source to destination, there are two paths possible. But among those all the paths which is possible to reach from source to destination, we have to calculate the maximum probability. Like you have to, if P1 is the probability of this path and P2 is the probability of this path, then one probability will be P1 into P2. Accordingly, you have to find, because it has been defined in the problem that you have to find the multiplication of probability, not the addition of probability. Okay, so after this we'll read the statement, and then this you will get what I'm telling. So these are the probability of reaching from source to destination if you are following this path. Okay, so and P3 and P4 is another probability of probability of the path, to reach from source to destination. And if you are following this path, then this we are going to get the probability is P3 into P4. And you have to calculate the maximum among these two probabilities, P1 into P2 and P3 into P4. You have to calculate the maximum. Okay, you have to take the maximum, and whatever maximum probability this you will get after calculating uh, uh, all the probability, the multiplication of all the probability, basically multiplication of the probability of the possible paths. You will have to take the maximum, and you have to return those maximum probabilities. Okay, so if you will read the statement, then see, you are given an undirected graph, weighted graph. Basically, you are given weighted graph of n nodes, and which is zero based indexing, represented by edge list, where edge of I is equal to a comma b, and basically it denotes the connectivity of a with b. Like a will be connected with b. Okay, is is an undirected graph. Graph is basically undirected, not directed graph. Okay, connecting the nodes A and B with a probability of success of traversing that is success probability I. This is another array, a probe I. Sub probe I is basically denoting the probability of path I. Given two nodes, a start and end, find the probability with maximum probability of success to go from a start to end and return its success probability. Okay, your answer will be accepted only when only when your answer is differing from, if your answer is differing from the exact answer by at most this, like 1 in 5. Okay, 1 in minus 5. Hmm. So this is your problem. If you will see, if you will see the test case one, then this you will get. There are two possible path, to reach from 0 to 2. Basically 0 is the source node and 2 is the destination node. The probability of those paths is zero point 0.5 into zero point 0.5, that is 0.25, and another probability is zero point 0.2. These are the probability, okay? And this is the maximum, like which is maximum on 0.25 and zero point 0.2, obviously 0.25, okay? So you have to return those the maximum probabilities of the path. Again, if you will see this case, then which is maximum possible? 0.30, okay? See, in this case, it is not, your starting node is 0 and ending node is 2. And if it is not possible to reach, if it is possible to reach from a starting to in node, no, it is not possible, because those two nodes are not connected with by any means. Like there is no any path, there is no any existence of path between those. Like they are not connecting, okay? And if component are given in this case, then you are always going to get 0, because there will be, and suppose your starting node is in one component and your ending node is into another component, then you are not you are not able to reach the from source to destination. You are not going to get this any probability other than 0.00 something like that. Okay, so basically these are the problems. This is the problems, and you have to solve it. So after reading this problem, what will you think? What this will be this your approach? Like if you want to do something, then please pause it and give a try. But if you are not able to think anything, then just be with me. This I will be explaining each and every part of these problems, and this will feel like this problem is too easy. Okay, because I'm going to solve it easily. Okay, so first of all, what will you think, like after reading these problems? This you are going to think about Dijkstra, but Dijkstra will work in the case like you have, if you want to find the minimum possible or the cost, like that kind of things. But in this case, you have to find the maximum. You have to take the maximum of each and every probability. So what will you use? Basically, this you can use Dijkstra algorithm in this case also, but you have to do slight modification in that algorithms. Like you can't use Dijkstra as it is, Dijkstra as it is, and because of that only this question has become interesting. And there is nothing in in these problems other than that. Okay. So what slight modification you have to do? Basically, what you are doing in Dijkstra, you are using the mini. Like you are using mini because you have to take care of the minimum possible path, to reach from one node to another node. Okay. So that this you are using the mini. You are using mini. But in order to solve this problem, instead of minif, you have to use the maxif. That is the catch. Okay, that was the catch. And you have to use maxif instead of minif. Hmm. Okay. Okay, got it. Up to here, this we have decided. We have understood that instead of using minif, because we were have to find the minimum kind of things, like we have to find the minimum cost, minimum uh, everything, minimum time, to reach from source to destination. If these type of things are asked to be find, then this we are using the extra as it is. But in this case, we are asked to find the maximum kind of thing. So we can't use the extra as it is. So we are looking to do some of the modification in that algorithm. The first modification that we are thinking of about is, instead of using minif, we are going to use maxif, because we have to find the maximum kind of things. Okay. So this is the first modification. Instead of minif, we are going to use maxif. And what will be the next modification? Basically, this is the major modification that we are going to do in this problem. Okay. And another modification is that, to not get TLE, like if you are given the constant, if given constant is too high, then obviously this will apply these algorithms. uh, without taking the care, like you have to take the care about something that I'm going to discuss right now. If you are not taking if you are not thinking about that, then obviously you are going to get TLE. But this I will be I will be I will be discussing some of the catch that this you can use to just not get the TLE. Like if constant is too high, in this case this will be this will get accepted too easily because constant is too low. But if you are going to solve some of the good problems at different platform like CSS, then you are going to get TLE because their constant is too high and their constant is also too good. Okay, so I'm not going to discuss about the constant, but for knowledge, I'm going to discuss like what another modification that we are going to do in the extra. Suppose this is your the node. This is the source node, and from this source node there are a lot of nodes. Like this is these are the nodes. Okay, and in order to reach from this node to this node, your given probability is P1. Suppose in order to reach from this to this node, given probability is P2, and in order to reach from this to this node, given probability is P3. Okay. So tell me one thing: which path will you consider in order to reach? Suppose your destination node is here. So which path will you consider in order to reach from source to destination node? Obviously, this you will think about which probability is maximum among all these three. If if this probability is if this probability is itself minimum, then 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 the probability suppose this and this this is not a, suppose this is not your source node. I'm going to make it general. Okay, so this is not your source node and this is some general node. Okay, so and we are this we are visiting this node from some another nodes like some xyz nodes. Like there are a lot of nodes and we are visiting this node from a lot of several nodes. Okay, and the probability of visiting this node is something like let it take it p5. Okay, and p1 is itself see what I'm telling. P1 is itself the smaller than the P5. Then will you take this? Because if you will multiply this P1 probability P1 with this current uh, P5, then you are always going to get this inequality like P1 into P5, because both P1 and P5 is between 0 or 1, because your probability will always exist between 0 and 1. So both P1 and P5 is between 0 and 1, and P1 is itself smaller than P5. Then multiplication of P1 and P5 will be smaller than P5. So will you take this P1 in your the probability P1 in your consideration? Like will you include this part? Obviously no, because this probability is will always give you the smaller probability. What this you are looking for? You are looking for any probability that after multiplication of those probability with the current probability, it will give the maximum probability than this. You are looking that kind of path. So this obviously you will not include this part. Okay, so first of all, if this case is not if this case is not satisfying, like P1 is smaller than P5, if P1 is greater than P5. Okay, and also this every P1 and P2 and P3 is greater than P5. Okay, so among all those three probability, which probability will you take? Obviously the probability with maximum value, because the probability with maximum value will always give me the maximum probability, because the product will give me the maximum probability, and obviously I will consider that probability. Okay, and suppose this is your destination node. Okay, this is your destination node, but this probability is not this node is not reachable. Like this is not only this node is reachable to the destination node, and this node is also reachable to destination node. Then and suppose P3 is maximum among P1 and P2 and P3, then will you consider this P3? No, this will not consider this P3, because P3 is this node is not reachable to the destination. There is no benefit of considering P3 as our path probability. So basically, this is also excluded. So which probability will you take? Obviously, we will take the maximum among P1 and P2. So in this way, the CV, you are going to select which path is beneficial for me, because I should take only those paths which are going to give me the maximum probability, and accordingly will reach the destination with maximum probability possible. Okay, so this was the catch of this problem, and I think I have explained each and everything. So let's jump to the coding part now. Okay, so this was my code, and so see what I have done is that first of all I had created this adjacency list. Okay. Hmm. And I think if you are knowing the extra, then you are familiar with adjacency list, how to create it from any 2D 2D vectors or array. Okay, so this is the creation of uh, adjacency list. Let me mm, adjacency list. Okay. So this is I'm creating the adjacency list, and this is the DIST vectors. Basically, DIST, the work of DIST vector is as similar as what you are using in the extra. So I don't have to do, I don't have to explain these things. And see, this is priority queue, and this is max heap. Okay, so this is max heap, and in the extra, what you are using? You are using minip. So instead of minip, you will have to use maxip. Okay, so first of all, what I will take, I will, as it is, I will always take the starting node, and the probability of that starting node is always one, because this is the maximum probability. And after that, when because probability can't exceed one, so I have taken the maximum probability. Okay, so no need to explain this thing also, because you already know what it is. Okay, so this is just like pushing the node. And okay, so I don't need to write any comment here. Like this is also the distance of a start node. The probability of the starting node is 1, so I have to insert it at as 1.1. Okay, 1.0. So I will what I was having the maxip with pairs, and it will basically contain the distance. It will contain the pair of distance and node. So basically, first part is distance, and these things was the similar thing that we have discussed. Like we always have to take care about this. If current current probability is lesser than the probability what we have, if this is happening, then we just have to continue with our iteration. We don't have to go further, because this probability will not give you the maximum, the product of the probability further. So no need to consider this probability. Okay, so this thing we have discussed about. So if I will be explaining this part later on. So first of all, let's see. If p dot first is less than distance of p dot second, basically distance of p dot second is the probability of node, this what we have present, what we have in maxi at the top. Okay, and similar thing I did as it is in the extra. You can see here. If you are not able to reach the destination, then you are going to return the 0.00, that's that way. And suppose if you are in any iteration, if you are reaching to the end node, then you just have to return the first part of the first part, p dot first, because p dot first is always containing the maximum probability of reaching the node, ith node. Means if you are p dot first is always containing the probability of product of the probability of reaching the ith node. Okay, so basically if you are at any iteration, you are at in the node, then you have to return the p dot first. Okay, so these are the code, and this is basically the simplest one. Like I had kept it as simple as possible. So this was the discussion. This was the problem that I want to discuss with you. So for now, thank you.